Okay, sawa.
Okay, so we're going to continue from where we left off from last time. Okay, so just to do a brief recap. So last time we covered topic modeling using bag of words, and we also covered topic modeling using TF-IDF. So I think I'll just go through the TF-IDF one because I think that's where we ended the meeting. So I'll just do a brief recap on TF-IDF and then I'll go to Genism. So okay, so TF-IDF majorly is used when you want to get the importance of a particular word in a sentence. So when we want to use topic modeling with TF-IDF, it means that we are taking that importance of that particular word to get a topic. So a topic is made by joining multiple words. Okay, so this is what we did last time. Okay, so you get the TF-IDF using this particular function, and then this is the data that we're going to work with. So you can be able to see this is like the index of that particular word and the weight of that particular word. So that's the TF-IDF. So I'm not going to go deep into what we did. I'm just going to go through what we covered last time. So after that, you create a dictionary and a corpus. So the dictionary is going to contain the words that are contained in that particular document. And for this, for our case, these are the tweets themselves. So we are going to take the words from the tweets. And the corpus itself, we now create a corpus from the processed docs. So the processed docs was, this was the processed docs is the data that we're going to work with. So that is what so the processed docs, this is the data that we're going to work with. And from the processed docs, we created a dictionary. So the dictionary has the specific words, and then we create our corpus. So you can see the corpus will be a list of the sentences that are in the processed docs. So after doing that, you can run your LDA model. So this is the function that is used to run LDA model. So LDA is an algorithm that is used to get the topics. So it's used to it's used for generating topics in a particular corpus. So this is the function that we're going to call, which was LDA multicore, and you pass in your data. After that, you need to specify the number of topics that you want, and then you pass in the dictionary that you created. So these are the words. This is the document that you want to check to generate the topics. And then you pass in the passes and workers. So from last time, I think we had, okay, so we had reached up to running the RDA using TF-IDF. So this is what we came up with. So yeah, so these are the topics that we came up with. You can see the values and the specific words that were being generated. So each and every topic has a particular weight that is related to each and every word. Is, let's say a word can appear in several topics, and the weight of that particular word is the one that will give it a weight, a particular weight in that sentence. So if you have a topic, you will have each and every word with a particular weight. So we can get the the words that have the highest weight. So those are the most important words. So you can see that is the output that we got, and if you want now to get the topics using LDA, you now pass in the TF-IDF corpus. So select the number of topics and our dictionary. So for this particular, this is a for loop to loop through this particular. So after you define your function, your LDM function, you pass in your data and your dictionary. We are going to assign it to LDA model TF-IDF. So we're going to loop through that LDA model TF-IDF, and we're going to print the topics in descending order. So the -1 means we are going to print them in descending order. So if you want to print them in ascending order, you can just use a 1. So you print the word and the topic itself. So each and every word will have a particular weight. So after running our LDA using TF-IDF, so I think I should run this. Okay. Running our LDA using TF-IDF. So we're going to print a particular corpus like this one here. So you have the weight and the topic itself. So the topics will arrange the words in descending order based on the weights of the word. So the difference between the bag of words and the TF-IDF one is just the document that you're going to pass. So for TF-IDF, you pass in the document that has been converted using TF-IDF. So we have a corpus of TF-IDF. For bag of words, you use a corpus for bag of words. Okay, so is there any question up to there? Any question up to using TF-IDF? So we covered this last time. So my main focus is to get to LDA using Genism. Is there any question for TF-IDF? Okay, so after you build the model, now you can get so for this particular line of code, we are taking the documents. These are the processed documents. So without even doing the LDA or TF-IDF, so this is the first 15 rows. So that's the function of this particular line of code. I think it is.
So
Okay. Okay, so I think I changed something on the code. That's why I'm getting the errors. So I want us to resume. So that's the part that we had not covered last time. So this is just for this particular, the ones that we covered last time, using get topic modeling using bag of words and TF-IDF. So that is just another way that you can do topic modeling. So it is based with what we covered previously. So we were trying to use the model that we had previously used, which was TF-IDF and bag of words. So this is another way of doing topic modeling. So you can do topic modeling using Jainism. So to do so to use topic modeling using to do the library that we're going to use, and from this library, so we just do the same as we did above. You create the dictionary using the processed docs. So the processed docs is the tweets themselves, the ones that we had already cleaned. And the corpus, now we create a corpus. So we'll have a dictionary and a corpus. So this particular corpus, if you notice, we are using Dr. Bao. So it will convert the words, the text into numbers. So we'll have a corpus of numbers and a dictionary of the words. So if you look at the dictionary, let's say the first value, if you look at the length of the dictionary, so this is the one I ran previously. So my dictionary had 19,000 tokens. So the tokens are the words. And then the corpus, now you can see the words have been converted into numbers. Okay, so you can see the words have been converted into numbers. So we need to have the dictionary and the corpus. So this is the corpus that we are going to work with. So we've just converted the words into numbers, and the words came from the tweet column. So for this particular part, I just want to save my model into, so for this particular, I'm dumping it into a file. So this is the corpus. I want to dump it into a file, and then I save the dictionary. I can now be able to use these two files anytime I want. Okay, so if I had run up to here, you would have seen the files appear on this side of the screen. So now to do topic modeling, we now import Jainism. So Jainism is the library that we're going to work with. And we define the number of topics. So this is not a must. You can just define the number of topics inside here. Cell.lda. So we're working with LDA, the LDA model. So this is the model that we are going to specifically work with. So we have other models. We have another model for semantics, but for this particular one, we are going to work with LDA. So you pass in the corpus, the number of topics. So for our case, the number of topics is 5. And then you pass in the ID word will be the dictionary. So we save the model as model.jainism. So model5.jainism, because we're using 5 topics. So after saving the model as model5.jainism, so we can work with that file. So even that file is supposed to appear here when I run it. And then now we can now get our topics using that LDA model. So to get the topics, you use the print topics. So this is going to give you the topics, and this is the library that we're going to work with, the LDA model. So the number of words, we want 6. So the 6 means that this particular topic will have 6 words. So each and every topic is going to contain 6 words. And so to do that, the print topics is going to also give a value to each and every word. So for these 6 words, each and every word is going to get a value, and this value is going to rank it based on the topic that it is going to be contained in. So we create a for loop to loop through the topics that have been created. This is the function that is going to create the topics and get the values for the topics. So if we print the topics, these are the topics that we got, the first 5 topics. So for topic 0, you can see the one the highest was Ikokazi, K. So I think the E is as a result of lemmatization. So we see the second one is Ikokazi, and then we have this one, the non-ACII words. So I think these are the values that they are not actually words, so they don't have any meaning. So I'm not sure how. Also, you can see the values. It has a high value based on this particular topic 0. So let's say, so for example, if we decide to go with topic 0, uh, Ikokazi KE will have a heavier weight than the word that is coming after it. And so this means that this particular word is going to be given much more. So we're going to consider this word more than we're going to consider this one here. But as you can see, we still have some words which don't make meaning, and they are being given a higher value. So this means that our model is not that perfect, but we can still get to pick out those topics for each and every. So the topics themselves have been generated from the corpus we had. So if let's say we want to get an input, so these topics have been generated using this function. So these are the first 5 topics, and you can see for each and every topic we have a word and its value based on that particular topic. So you can see how each and every word contributes to the topic. So let's go to ahead and try and test this particular on a new document. So to test on a new document, let's say our first test. So we define the test sentence. So this is what we're going to pass in and test to see if a model will be able to get the right topics based on what we've just entered. So if you notice the new doc, which is this particular sentence here, is not related to the project itself, which is trying to find job opportunities and such. So we want to see how the model is going to perform based on a sentence that is not related to what we want to get. So we need to convert this particular sentence into a format that we can now be able to work with LDA. So we pre-process the document first, and then we convert it into numbers. Then so we'll have a new a new uh, a new data set or a new document that has only numbers. And so you'll have a value for practical, you'll have a value for Bayesian, you'll have a value for optimization. So if you print that document, this is what we're going to get, the first line and the value of how many times that particular word occurs. So for practical it's 1, for Bayesian it's 1, and optimization is 1. So we then get to print the document topics. So by topics, we're going to get the weights of that particular word in that sentence. So you can see practical has a 0.03 and so on and so on. So each and every word has been given a weight. Okay, so our dictionary, if we just get our dictionary, it's still the same. You can get any number. It will give you the particular word in that that is located in that particular index. So this is just but random indexes. We want to get to see the particular word that is in that index in the dictionary. Okay, so for here we want to get for 10 topics. So you remember what I had done earlier. We did for the first 5 topics. Now we want to get another model for 10 topics. So to do one for 10 topics, you use the same module. So we are working with LDA model. So this is how you call the LDA model. So genism.model.lda model. So you call the LDA model. So you pass in your corpus. So this is the corpus the corpus is the one that we had earlier. So still, I want you to take note, we still haven't used this, we still haven't tested using this particular word sentence. So, but we've already defined anything. So I'll come to use it later. So I hope you'll still be able to follow. So for this one here, I want to get the first 10 topics. So I'll implement the model below after I have everything that I need, the first 5 topics and the first 10 topics. So to get the first, if you want to get for the 10 topics, it's going to create 10 topics for you. And the number, so you just define the number of topics as 10. So the previous one, we defined the number of topics as 5. Pass in the dictionary and your data, which is the corpus. Then you save it into a file. So this is model 10.genism. So after saving it into a file, you can now print the topics using lda.printTopics, and you define the number of words. You can have 6 words in a particular topic, or so for this case I went with 4. So I wanted to have a topic that has only 4 words. So you print the topics by looping inside the values in topics, and then you print the values. So let's go ahead and yes. Okay, so you can be able to see each and every word based on, this is a particular word in topic 0. So this is a topic 0. We have work, we have look, we have interest, we have vacancy. And work has the highest, followed by look, followed by interest and vacancy. So you can see if we use the number of topics as 10, we are getting to find the words, the specific words that we were trying to look. So we have work, we have job, we have pata kazi, we have hire. So you can see it's a little bit better, and our topics are related to what we're trying to achieve. So this is another way to now visualize what we've just created. So these are the models and these are the topics that we came up with. So based on these topics, we can now be able to visualize into an interactive visualization so that we can be able to get better insights from the topics that have been generated. So Pile Davis is a module that can be used to plot the topics. So to use Pile, this particular module, you'll still define the dictionary. So our dictionary this time will be the dictionary that we loaded as dictionary.genism. So if let me go back to where we saved the dictionary. Okay, so this is where we saved our dictionary. So we saved the previous dictionary. So the dictionary that we were working with, which is this. Let me show you. Okay, so you can see we defined the dictionary and we defined the corpus itself. So we were working with the corpus. Now we want to plot, but to plot that we need to make use of this dictionary. And to make use of this dictionary, that's why it's just the same as this one. So that's why we save. Let us go back to plotting. Okay, so you can see this is the file that we are now loading, and we assign it to dictionary. So you can still work with it. So we are loading it from as a file, and you load the corpus still as a file. And this is now our LDA model. So you import the LDA model the way we were importing it just above, but now you add another function, which is the load function, and you load that particular file. So this particular model is model 5. So remember, we have model 10 and we have model 5. So to work with, so that you can plot it, you install the library. This is the library that we're going to work with to plot. And so the reason as to why I used pandas 0.2, 0.25.1 is because I had to update my pandas so that I can work with this model, this particular library. So that's why I added this particular line of code. So to plot is pretty easy. You import the library and genism. So remember, we were working with genism, but now we want to plot. So you import genism from Pile Davis. So after doing that, you import genism. So we've been imported this particular library. So that's what we are going to use to plot. So to plot, you just prepare. You add another function, the library plus prepare, and then you pass in the LDA. So LDA, let me show you where we added, we imported. So the LDA is the model that we were working with. So for this particular one, we are working with the a model of 5 topics. We just want to get a model with 5 topics. So that's our LDA. So this is what we are using to plot. And then we pass in the corpus. So this is the data that we want to plot, and our dictionary. So the only difference is this LDA is the only thing that I think is a little bit tricky. But what it just does is that it's trying to get from the model that we saved as model 5.genism. So remember, model 5.genism contains the specific topics that we created from our data. So it's going to refer to this particular model as it tries and plots the values based on this particular corpus. And then the dictionary it's going to use is the dictionary that we initialized above. So we don't want it to sort the topics, but you can sort the topics and as true, and it will automatically sort your topics. So to plot, you just display, and you display this LDA display. So it's going to display the values based on their topics, and you can be able to now have an interactive. You can now be able to interact with the visualizations themselves. So here you can be able to define, to select the number of topic that you want. So let's say I want to use topic 1. So the topic 1 is going to be generated from that model that we saved, which is model 5.jrism. So if I select topic 1, these are the words that are going to majorly appear. And you see, if I hover upon a word, you can see that specific topic is going to be highlighted, where this particular word has a higher weight. So if I go to the next one, you can see the topics are changing based on where that particular word is situated. So you can see I selected the topic as 0. That's why most of the words are based in this topic. So you can be able to just check and have a better understanding of the topics that have been generated, and each and every word, where does it fall under, and which topic does it contribute the most to. So there are some key terms that they will be generated by the plots. So to explain what this plot is all about. So we have this particular term, the saliency. So it's a measure of how much a term tells you about the topic. So what this means is that, let's say we have something like internship. So you can see internship is majorly, it contributes more to topic 4. And then we have the red color, which is the estimated term frequency within a topic, and we have the blue one, which is the overall term frequency. So you can see for something like internship, it doesn't have any. The estimated term frequency within that particular topic is let's say it's almost close to 0. But you can see it depends with the topic that you highlight. So those are the values that we have for the estimated term frequency within a selected topic. So how frequent does that particular word appear in that topic? And we have the overall term frequency. So how many times that particular topic appear in the whole corpus for the topics that we selected. So that we have the relevance. So the relevance is just the weight of that particular word in a particular topic. So you can see a word is given by the topic, normalized by the probability of the topic. So the probability of the topic is the values. So let me show you. We have something else here. So this one now gives you a relevance metric of that particular topic. So if you want a relevance of, let's say, 0.4, it's going to automatically give you the topics with this particular relevance. So it's going to only consider the topics with a relevance below 0.4. So you can be able to have a view. Sorry about that. So you can be able to have a view of the relevance, how relevant you want a particular topic, how relevant you want it to be. So if you want a relevance of 1, it means that that's the highest relevance, and it's going to give you the topics with the highest relevance to the lowest. But if you just want to have a specific point that you want to get the topics, let's say 0.6 and below, that's the relevance of that particular topic. So you can be able to define it to use the slide. So I can now show you another plot, which is the last plot. And this is for the model with the 10 topics, the model that we used 10 topics. So this one was a little bit different, as you can remember from the topics themselves. So let me show you. So this is for topic 5. Let me show you the values that topic 5 was generating, so that you can see the difference between the values for topic 5 and the values for the model for topic 10. Okay. Yeah, it's here. So you can see this is the ones for we were generating for. So for this one we were generating for 6 number. The number of topics is 6, and for 10 let me show you for 10. So for the model for 5 I didn't print that one. So let me show you for 10, so that you can see the difference between the two models. So this is what we generated for 10, and this is what we are trying to plot. So the reason as to why I'm showing you this is so that you can get to know, to understand how the visualizations are working, because the visualizations are based on the topics that we generated. And remember, this is just but the first 9 topics. So the topics that were created, let's say when we used the number of topics as 10, we have a lot of topics that have been generated. And these topics are the ones that are going to tell how much a word is important in a particular topic. So the first visualization was for 5. So you can see this is when we use 5 as the number of topics, and the second visualization is for 10. So for this particular one, you can see the values based on the topics where they which they contribute for. So okay, yeah, so you can be able to just go through, have a better understanding of each and every word, how it contributes to that particular topic. So the topics are the numbers that you can see on the left side. So if you hover on top of a particular topic, it's going to give you the word that has contributed the highest. So for topic 9, you can see vacancy has the highest contribution. So that was all I did on LDA. So yeah, I think that was all I did on LDA. So if you have any question or comment, feel free to ask. Okay, Eunice, I think I can pass it over to you. Eunice on the call. I think Eunice is not on the call. So is there any question on topic modeling, either on bag of words, TF-IDF, and Genesis? Okay, so I think that is all I had to offer on my side. So I'm seeing Eunice has dropped off the call, and there's something she wanted to share.
Paul.
Yes.
And just say great work, and thank you for sharing your knowledge. If it's you may share you will share the recording as early as possible. Some of us have been dropping out. Okay, for me, let me speak for myself. I was not there through the whole
Okay.
process. If you share it as early as possible, it's great.
Okay, so I think I'm going to share for the one for the last time. I'm not sure that it has been posted, but we already shared the recording. So for this one, the one for this particular one, Ayub is recording it, and I think he's going to post it immediately.
Okay, okay, okay.
Yeah. Okay. Eunice.
Yes, Paul?
Okay, so I think I'm done.
Oh, yeah,
I'm
I'm
done.
so
I'm done with,
sorry.
yeah. So there's
Um,
something you wanted to share.
yeah, I actually left you at, you see where you are differentiating between the 5 topics and the 10 topics, the model.
Yeah.
So
Yeah.
nikapata blackout, so nimetoka hata see I was recording but I can't. But just a question.
Yeah.
Is there a difference in the model? Because I could see the output of the 5 topics and the 10 topics, but is there really a difference in the model because we are using the same dictionary?
Yeah. Yes, I think there's a difference in in the models, but the only difference is that, let's say, when you define the number of topics, the number of topics is just how many topics are we, how many words are we going to combine to create a particular topic. So if, let me show you for this one here. So if you define the number of topics, so it's going to return this number of topics. So it's going to combine different words and then come up with 10 topics. So if you define as 5, it's going to combine again the words and come up with the topics themselves. So I think there's a difference between if you define it like 10, it means you just want 10 topics. So it's going to come up with 10 topics based on the words that you have on the corpus. If you define it as 5, it's going to come up with 5 topics based on those words. And remember, the topics are created based on how a word contributes to that particular topic. So I think those topics will be different based on the value that you define for the number. So you can be able to see there's a difference between these topics that have been generated when you used the number of topics as 10 and this one here. Yeah, so you can see if we use the number of topics as 5. So for this one, we just want to get the first top 5 words, top 9 words. So I think here we want 6. Yeah, so you can see if we use the 5, the 5 topics, the number of topics as 5, we are having something like non-ACI word having a very high value in topic 0. So you can also see in topic 2, we have this particular word having a very high value. But if we increase the number of topics for our model as 10, we are getting a very interesting change in the number of the topics being generated. So the number of topics you define is going to define the topics that are going to be generated. So you can see for this particular one, we don't have any word that maybe we don't need. So you can see non-ACI word is coming in topic 6. So if we just decide to work with the first 5 topics, we're not going to get any problems with these words.
Okay.
Yeah.
So you want to say the more the number of topics the more accurate words you get?
Um, I will say I'm not sure, but I will say it just depends on try and error. So you'll try to see if I use this particular value, is it giving me a better outcome than using the other value? So it's just for you to try it out and see which one works best. So maybe if I used maybe 7, we don't know if it will have given us a better topic, but for this particular project I used 5 and 10 to compare between the two, and the outcome we see the one with 10 has the best. So based on this we can say, yeah, if you increase the number of topics you get a better performance.
All right. Yeah, and last time when we were having the session, I remember there's some questions that came through, even when you could not respond to them. So do you mind like making it clear why exactly we are doing topic modeling and how will it help in our training the model?
Okay, so the importance of topic modeling, we can now be able to know the particular topics that we are working with. So let's say for this particular one, we have a topic that has been generated that has work, look, interest. So if we want to, let's say, recommend something to someone, we can recommend based on the particular topic they are searching for. Say, let's say, um, let's say for example, these are the topics that are being we came up with. So we have work, we have job, we have vacancy. So we can now be able to differentiate between a tweet that a person who doesn't want job recommendations and a person who wants job recommendations, because we cannot be able to extract the topics from the tweet of a person. So let's say a person tweets something like, I'm looking for a job. So it's going to get those words and then try and check from the topics that we have from that particular model. So this is the topics that we have for this particular model. Then it tries and looks. We have look, we have this and this. So it will. We are now going to be able to know for this particular tweet, this particular person can recommend them a job, but for this one you cannot recommend them a job, because if we try and get the topics from the tweet they tweeted, then we, let's say, we don't get to, they are not that much important. So it depends with the tweets, and these are the topics that we are going to be counter checking with. So I think the most important thing with topic modeling is that now you can now be able to know what you're working with and what you want to like recommend somebody.
Oh, great. Thank you, Paul. Have you handled, people have asked questions and you've handled them, right?
Yeah, I think there's up to, by the time we were joining, I don't think there were any questions. Yeah, so we were waiting for you to, there's some questions where you are supposed to clarify from last time.
Yeah. All right, Sawa. So it means nobody else has a question for you right now? It's okay. Okay, then you can let me share my screen, please. All right, so can you guys see my screen?
Yes.
Oh, great. Okay, so last time we
Yeah.
did word to vec, and there was a question here. Here, exactly here. When we wanted to just know the frequency of our words that were stored in the dictionary. Remember, we had this function. We had this. We were creating a dictionary here that will hold our words here, and then we wanted for each and every word, if it's present, it will be given a count of 1, and if it's already in our dictionary and it appears again, the count will be increased by 1. The increment, there will be an increment here. So the problem we had was we were getting a job having 118 here, and then later on we see job having a count of 115, and people were asking why are the counts changing the frequency. So initially I thought this code would, because I had included this part, a loop that checks the whole corpus, the whole of my corpus, because it had the text. So the problem was, I thought that for every loop, if it gets to the 51st sentence, job, the count that job will have is the cumulative count before, since the count started at sentence 1 to where it is now. If job had a count of, in sentence 5 it had a count of 5, I expect it in sentence 10 to have a count of 5 plus something, maybe 5 plus 2, to have a 7 or any more than the count that was previously recorded. So that was not happening, and we tried to brainstorm why it was not happening like that. And this is what I found out. So I was doing my loop wrong. So I decided to just deal with my words. So these counts here, they are shown for each and every sentence. So it means in sentence 4057, job was appearing once, seekers was appearing once. But you can see in 4051, job was appearing thrice, and hunting was appearing twice. So this is a breakdown of how my words were, the frequency of my words in each and every sentence. But now I wanted to see in my whole corpus, after removing the stop words after tokenizing, what is the frequency of my words. So of course I couldn't view everything, so I just came and looked at my top 10 words in my whole corpus. So now this, we could get Ikokazi KE has 12,717, appears 12,717 times in my whole corpus. So this is what was confusing us, and I was able to differentiate this and this. At least this you can see is for each sentence, and then this is for our whole corpus, what was happening in our whole corpus. Yeah, so that was the only question that we had last time that we could not address. And yeah, so yeah, that was it. I hope all of us here were in last time, because if you are not, then you would not understand why I'm answering that. But if you go through the video, there's somewhere you'll see we were stuck for a minute, and this is the explanation. So if you haven't gone through the videos, then kindly do. I'm not sure Ayub has posted them yet, but I'm sure he'll address that before we finish today's meeting. Yeah, so let me stop sharing, or is there any question? Eric, you were there. I remember, Kwanzaa, you asked so many questions. Paul, can you guys hear me?
Yes, we can hear you.
Oh, all right. Sawa, so if, do we have any questions? People are so quiet today, wow. It's okay. So I'll just stop sharing and then, oh, sorry, yes?
100% understanding.
Yeah, let me assume that. I know that is Timothy. Yes, let me assume that. Let me stop sharing and then, so we don't have any question for Paul. Okay, all right. So let me check in with Ayub, see whether he's available so that he can tell us what next. What is the next step after this? And then maybe he can share more about last time's recordings. Yeah, so let me just stop sharing and then try reaching out to him. So in the meantime, maybe you guys can brainstorm on what you think about topic modeling, what you think about Word2Vec, about bag of words, about TF-IDF, because now we've done all the three models. Yeah. So Ayub is coming in just a few seconds. He'll be right here. Yani nobody has a question today. Wow. Hey, 100% understanding. Paul, good job. Good job. Let me hope so.
Eunice.
Yes, please.
Good evening.
Good evening.
Yeah, his presentation was okay. Thank you so much, Paul. Some concept might take some time to sink in. So, like myself, I will go through the video again, the recording again, and I am sure come next session, the questions that will have come up, I will bring them up. So not that we don't have questions. It could have been maybe you don't know how to phrase the question because it could be something that you didn't understand, which come next session we will bring them up. The session was great though.
All right. Sawa Karo. Yeah. Tusumbue Paul na maswali. Next time tutakuja tumeelewa kabisa everything. I know it's a bit intense, but najua tutaelewa kila kitu. Yeah, thanks.
Yeah.
Awesome. Nimesikia Karo akifungua roho, which is good. Watu inafaa wafungue roho. Watu inafaa wafungue roho, which is good. That's the only way you can get value out of these sessions. Naona tumekuwa full house. Paul, sorry I could not be with you guys all through. There's something I had to attend to, so I left it recording. Immediately after this session, I had issues with the previous recording, so I'm going to try and do that with the help of Eric just now after today's session, and then make both recordings available. There is something that has kept me pretty busy, the interface which we will plug in this model so that any other person who wants to test the model that we will have built in class can actually log into an interface and interact with it. Other opportunities or other avenues you're looking at, one of us, Patrick and Seme has a Telegram bot. We would want to test the same interface with his bot. So anyone who logs in into his bot on Telegram, can they ask some basic questions on the bot? So once we achieve that, then we will now definitely focus more on how to optimize our chatbot and make it give value. So the first thing is the ability to expose this model that it can actually interact with the public. We are not looking at really the results as of now, but once we get the end-to-end connected, then we will have the class sessions will continue with the main intention to have like now deliver the value that someone can ask a question and get an answer from Twitter. Yeah. Okay, so those are the next steps. So that interface, I'm building it in Django. There are quite a number of interfaces. So it has really kept me busy. I wanted to complete it before I resume work, because when I resume work, it will be even much slower. But I was able to attend the first couple of minutes of your session, and once in a while I could sneak in and check out how the class is going. I'm also going to go through these videos myself. I learn the concept you've shared. I saw some really cool graphics. I said, okay, I really wish I could be in class. But thank God it was recorded. So I'm definitely going to go through it. Thanks, Paul. And thank you everyone for organizing this session. I hope it was worth it. Samson? Amwata? Sam? Unajua mi hupenda tu kuchokoza watu. Once in a while, mtu asiingie kama mimi alafu umeweka koti alafu unapotea. Leo nilibidi niweke koti. Nikapotea kidogo. Henry? I'll just call random names.
Hi, Ayub.
Hi, how are you doing?
Niko poa. I came in late, so I think I'll just go through the recording.
The recording, eh?
Nifuatilie where we are.
Cool.
Yeah.
Poa. Dan?
I came when the graphics were popping up. So
oh, you saw it. You saw the graphs, eh? Nice.
Yeah, that's when I joined.
Nice. So we all get time and go through it. Duncan? Mr. Duncan Uluma.
Hi guys.
Hi Dan.
Hope kila mtu ako poa. I'm sorry, I think I missed a couple classes last time. Though and catch up. Leo imekuwa sawa. Thanks to Paul. Though some concepts I still have to understand further.
Nice. Na unasikia ngoma mzuri sana. Zile za Eriko. Eriko, I hope you're excited. Daro ilikuwa aje?
Kwani kuna ngoma zangu na zenye si zangu. Ngoma zote as long as inaweza jazz. Nikibambika nayo niko sawa.
Nice. Ngoma kai.
Yeah, I enjoyed it a lot actually.
I was yeah.
So I'll be following up on the notes to really get deeper. Understand it.
By the way, Eriko, thank you very much for the work you're doing with regards to the Twitter and the data. So it's good to hear that the code is now working. We will end up having quite a lot of data to work with. So it's only going to get better. Thank you very much, Eriko.
No problem.
I kept sneaking into Paul's class and I was like, okay, I really have to miss these things. So Paul, prepare more content. And I know the more you teach us, the more the concepts sink in. So you're actually forced to research. You're actually we are putting you on toes.
The limelight.
And I think so far he has not let us down. So I really like what you guys are doing, and thank you very much. Davy?
Oh, good evening, everyone. So yeah, it was a good session. Paul explained everything clearly. We wait to see what we'll do next and how the chatbot will be done and how it will work. Yeah, very excited about the work we are trying to achieve. Yeah.
Awesome. Good stuff. Mr. Dennis mwenyewe ama mtambo imeenda maraundi? Deno anakuwa na mashida zingine ndogo ndogo.
Wewe wacha wewe.
Zile shida ushika Eriko.
Wewe wacha bwana.
Sema Deno.
Kesho nimekuwa fiti. Nilikuwa nishafungua roho wakati ulikuwa umehang.
Okay. Hiyo ni poa.
Bado tunataka hiyo recording. We need to get deeper. So ndo tuambushe msee na maswali next time.
Na maswali. Okay. Eriko, please stay behind to sort out your recording. So we see how the recording. I know the recording nimechelewa with a couple of them. I think 2. So we also need to figure out a way of ensuring that the recordings are immediately available when people need them immediately after the class. So I will improve on that. Eunice sawa kabisa. And then finally, Madam Omboi.
Hi, I was just about to leave actually.
Oh, is it? How was the session?
It was really good. I mean, it's always good to hear from Paul. I think because he was also my classmate in Moringa, so really amazing as well to see him grow this much. So yeah, it was a good session. Can't wait to see what this is about at the end of the day. Yeah, I'm excited about the bot actually. I'm really excited as well.
Good stuff.
Yeah. Maybe a question to you. Are we still launching it on the 26th of September?
That's what I'm. Sorry?
That was the plan, right?
Yes, that was the plan. So that is what is really keeping me busy with the interface, because I know once we have a model that can be able to do like 2 levels of classifications, then we will definitely be able to launch it on that date. So the only impediment will not be, it won't be actually the modeling, it's going to be the interface, the REST API. But once I manage that interface, we can even expose it on Patrick's Telegram bots.
I think I know what we can do about. I'll see what I can do about just taking people through the. Anyway, so I'll see what I can do about just helping people see like how it started to the end.
Nice.
So yeah, so I think I can come up with a write-up, and then we can just maybe do it in parts, and then maybe I'll see what I can do. I have an idea of how we can still showcase everything, but still have the main deliverable as what do you call it?
The bot.
As the interface, as a bot,
Awesome.
Yeah.
Okay, you could take lead on that. You just lead.
That's what I wanted to say before I leave.
Okay, awesome. Thank you very much for offering that. Of course, you can take lead of that. So you tell us, let us know what you need. You could speak to the guys directly. You've also been following up. So whatever you come up with, maybe one day, just before the end, you could tell us what plan you have.
Yeah, I'll just work on it. I think next week, and then I'll show you guys first before and then we can discuss this on the side as well.
All right, awesome. Thank you very much.
All right,
for offering that. Okay, cool.
Have a good one, guys. Bye.
Okay, cheers, bye. So guys, I think this was really good. Paul, good work. I'm looking forward to more content. I know, we'll head towards even a neural network. So keep the good work. Guys, the spirit, we should all maintain the spirit and continue working together and learning together. Eriko, tafadhali remain behind. Anyone else, you're free to leave at your own will. So Eriko, I'm going to, first of all, here, because this is still being recorded, I'm going to stop the recording and then you help me how we can put it together from a mail. I'm going to project my window. So let me just stop the recording.